Hello and what's up to you all pre-matriculants. This is Abram. It is a lovely Monday, a Triple M day. Mine, it is Maths Monday. Thank you for joining us and tell all your friends to join us as well. I'm not alone, I'm with Dina. Dina, how are you?
I'm doing well, AB, and ready for today.
Nice one. I'm also ready for today because it's all about maths. And talking about maths, we've got your notes, guys, on facebook.com/learnextra. But in case you missed any of our notes, feel free to go on learn.mindset.co.za. On the links that are provided for you on Facebook, there's the download, the view, and the test yourself link. If you test yourself, you get an opportunity to be drawn as a winner for this Casio calculator. But I must say that winning this calculator shouldn't be one thing that pushes you to test yourself. You should test yourself to see also your answers immediately. So guys, let's get entering because those questions are simple because you know that you are brilliant students. But during this show, we'll also be drawing winners for the Get Connected competition with prizes proudly sponsored by Vodacom. So airtime voucher winners will be drawn today. 3 of them are actually, yes, 3 of them for this show. So, Dina, you'll be helping me later on.
Awesome.
Back to you.
Are we ready to start?
Yes, let's start.
Fantastic. You know, AB really gets carried away there because he's got such lovely prizes to hand out later that he forgets there's actually a maths show. But here we are, grade 11s. We did some area rule, sign rule, cos rule last week, and I'd like to use those rules that we learned last week to solve some problems. And the problems are going to be 2-dimensional and 3-dimensional in nature. And I think the best way is always to start with a challenge question because that is really what some of you are waiting for, really to be challenged. So do go to the page to get the diagram. It's quite an intense diagram. It's got a lot of lines, lots of angles. And so get familiar with that picture and then send us your answers. We'll be looking forward to showing you or finding out how many of you were able to get it right a little later. So let's see what the challenge question is all about. Okay, we've got a diagram over here that shows point B, A, J, and K on the same horizontal plane. And then you've got D, P, C, which are points on a hill. And you've got some lengths. You've got that this length AB is 2,000 meters. You've got PB is 1,000 meters. You've got the angle of elevation from B to C is 30 degrees. You've got an angle from PB to CB at 60 degrees. And your job is to find out certain lengths. BC, we need to find out how long BC is. CK and BK. And these lengths here are really going to help you find the last bit of information, which is to determine what the length of AT is. So grade 11s, get cracking on that problem, while the rest of us are going to work through some very simple but interesting problems together. Now, as a matter of recap, just to remind you again from last week that the sine rule works in ratios of side and angle have got to be opposite each other. So sine A over A, sine B over B, sine C over C, those 3 ratios exist in the sine rule. The cosine rule is always the sum of the squares. So A squared is equal to B squared plus C squared. And we've got to take away minus 2BC cos A, where angle A and little a are opposite each other. And then the area rule is always a half of AB working with SAS, sine C, the angle between the 2 sides. So the cos rule works with 3 sides. If I have 3 sides, I can find an angle. Or if I've got SAS, I can find the 3rd side. So that's my cos rule regulations. And then I've got my sine rule, which is the information has got to be opposite each other. Okay, now we're going to use these rules in a 2-dimensional setting, but also in a 3-dimensional setting where we're working with a vertical plane, a horizontal plane, and an oblique plane. Let's go into our first question for the afternoon. And here we go. In the diagram, ABCD is a quadrilateral and AC has been drawn. AB is 70, this length is 70 units. BC is 60, AD is 50, and DC is 40. And we've got that angle ABC, this angle over here, is 34. Let's see what we need to calculate. We would like the length of AC. So here we have this triangle over here, where we would like to find out what the length is. So in this pink triangle, what have we got? So far, we have a side, we've got an angle and a side. What rule helps us to find the length opposite that given angle? It is the cos rule. So the formula for the cos rule is that AC squared is equal to the sum of the other two sides squared. So it's AB squared plus BC squared minus twice of AB times BC times the cos of that angle that's opposite the side, so times cos B. Now AB is 70 and BC is 60, and then we have the product of those two sides times the cos of 34. And that's going to give you AC. Now, grade 11s, it would be useful for you to just write what AC squared is using the calculator. So if we fill that information in, we have a 70 squared plus a 60 squared, and we're going to take away 2 times 70 times 60 times the cos of 34. And that is 1536. So write it in as 1536. Don't waste time writing what all those values are. Just do one calculation. And then AC as a follow-up calculation would be the square root of the answer that you've got on your screen, which would be 39,19. 39,19 in the same units that we're working in. And we're working in millimeters, so this would be 39,19 millimeters. Right, so we now have got this as 39,19, and our next question is to find the magnitude of angle D. Now we would like to find what the size of that angle is. Okay, so if we have a new triangle, because angle D is in this triangle ACD, then if we look at the given information, we have 50, we have 40, and we've just been able to calculate this third side. So in terms of the rules, we have 3 sides, and using the cos sine rule, the cos rule allows us to find our third angle when we've got the side information. So again, I wouldn't memorize a formula for finding the angle. I would just write down that the angle that is opposite that side, there we go. There's the angle, there's the side. We're now going to write AC squared. So in triangle ACD, AC squared is equal to AD squared plus DC squared minus twice of the product of the sides times the cos of the angle. Now just fill in all the numerical values and then solve for cos, instead of getting cos D as the subject of the formula and then substituting in. So if we substitute in first the values, AC is what we've just found. It's our 39,19. Our AD is 50 and CD is 40. 50 squared plus 40 squared minus twice of 50 times 40, and then this cos D where we're trying to find out what that is. Now we'll solve for cos D. That squared, take 50 squared to the left, take 40 squared to the left, divide by the coefficient, so it's negative 2 times 50 times 40. Let's just make this 50 look like a 50. And then that will all equal to cos d. So now our calculator will be able to help us to just simplify these values. So we have a 39,19 squared. Now, since I have it still on my screen from our previous calculation, I'm going to use all the values. I'm going to use all the decimal values. So that's squared minus 50 squared minus 40 squared. And I don't know why this little plus minus is in here, but it's minus 40 squared. Keep your eye on the screen to make sure that you haven't lost anything. Divided by, and we have this negative 2 times 50 times 40, and that's all equal to a negative 56, which cannot possibly be true. So let's just see where we've made a mistake. It was the 39 minus the 50 squared divided by, let's just see here, because you're subtracting the 50 squared, you're subtracting the 40 squared, and then you're dividing by negative 2 times 50 times 40, and we get equals. Now it's even giving me another answer. So this is very... Okay, let's start again. So we've got that 39.19, which we're squaring. We're then subtracting 50 squared, and we're subtracting 40 squared, and we get that. And then we're going to divide it by negative 100 times 40 is negative 4,000. So we're dividing by negative 4,000. Let's see what we get. Ah, that's much better. We're supposed to get a value that's smaller than 1, otherwise there is going to be no angle. So we've now got cos d as 0,64, which gives us an angle. Grade 11s, how do we find an angle if we've got a ratio? There's my shift button of our answer, and we get 50,1. So our angle D is 50,1 degrees. So using the cos rule in two situations, finding the length of the side and finding the angle, but utilizing the rule in its formula state, and then trying to solve for that angle. So good application of the cos rule. Okay, next question. The sketch below shows one side of the elevation of a house. Some dimensions in meters are indicated on the figure. So our units are in meters. And we have this length, DA, there's a perpendicular. We have BC, we have EF, which is perpendicular at G and F. We have 32 degrees, an inclination, we've got 7.5, and we've got this length is 9.4. And we need to calculate, rounded off to one decimal place, what the length of EC is, which is that length there. And we have to find DCE, which is that angle over there, and then we'd like the area of DEC. So it looks like that would be some kind of a roof or height structure. So, oh, and then we would also like to know what the height of EF is. So those four little questions. Let's see if we are able to find out how to calculate the length of EC. Now, I like to go to my diagram and mark the side that I need in relation to what I have. So if I have that length there and that length there, no, I don't actually have that one. So let's just undo here. There we go. So I've got that length, I've got this angle, Let's just fix this with our yellow. There we go. And we would definitely like to find out how long EC is. How would you propose grade 11s? We have 7.5, we've got 32 degrees, and we'd like to find that length over there. Okay. We could work in this triangle EDG and find out what that length is, but then we're still missing an angle over here. So there's a lot of information in that triangle that we don't have. So what are we missing? If we want to find the yellow line in the big triangle is opposite 32. And we've got the 7.5, which is opposite that angle there, but we don't have that angle there. So what would you use, grade 11s, to help finding some information that we may be useful? Okay, we've got to go elsewhere on the picture. And what we haven't used is this line AB. And some of you, I'm sure, are shouting at your screens and saying, why can't we use AB? If we look at AB, AB is the same as DC. We have this perpendicular, and we've got that perpendicular, so these lines are parallel, and therefore they will be equal in length, those pieces, because there's a perpendicular over here, so that will also be a perpendicular. So we therefore have that this pink is 9,4. Now, in this triangle, and I'm going to outline it now in yellow, in the yellow triangle, what have we now got? We've got side, angle, side, and so therefore we can calculate EC by using the cos rule. So EC squared is equal to DE squared plus DC squared minus 2 times DE times DC times the cos of angle D. And we're now going to substitute. EC squared is what we want to find out. So we substitute DE, which is 7.5 squared. We're going to add DC, 9,4 squared. And then we're going to take away the product of the two sides. Okay. And times the cos of angle 32. Okay, so if we take our calculator. Okay, we just need to move down a bit. Just see if it fits. Okay. So we've got 7.5 squared, 7.5 squared. We're going to add 9.4 squared. We're going to take away twice of those two values. Keep your eye on the screen. Is everything okay? Times cos 32. And we get a squared value of 25,0. So that's our squared, which means if we take the square root, we get a 5. So EC is actually equal to 5 units. From all this, we can say EC is equal to 5 meters. Okay, I think, AB, we're ready to have a little break, and we'll come back and do the rest of the question.
Awesome. And during this break, Mindsetters, you have the challenge question. And remember to register on moremaths.org, because that is an app that will test you with other Mindsetters and see who has the top score. Your code is 0JRN. It's all posted on Facebook. So we'll see you after this break. Welcome back, awesome pre-matriculants. Now we do see your questions over the page and we are taking note of them, but remember also to answer the challenge question. But for now, Dina, exciting news, we're giving away 55 Rand airtime, proudly sponsored by Vodacom, to one lucky Mindsetter, and then we're going to draw 2 other names later on the show. So guys, if you've entered the Get Connected competition, your name might just be drawn. So Dina, ready?
Good luck, everybody.
Yeah.
Here we go. Ooh, I can't look.
Yes.
Okay, I'm not looking. I'm not looking. I'm looking at you.
And the winner is Mpo Mulo. Congratulations to you, Mpo Mulo. You're getting yourself 55 Rand airtime voucher, proudly sponsored by Vodacom. Hope you're going to call us.
Nice, Mpo. Well done, Mpo. Thank you for entering the competition and enjoy using your airtime. Can I
Yes.
carry on? Okay, super. Right, grade 11s, let's get back to the house question. We were finding the length of EC. We found that it was 5. Let's carry on and find the next little bits. Let's find where our question is. There we go. Right, we found that, so now we need to find DCE. Who is DCE? There we go. It's this angle over here. We want to find angle C, this one here. And grade 11s, how do you suggest we find angle C? Angle C is opposite 7, 5, and we've just found that that's 5 and it's opposite 32. So when information is opposite each other, we can use the ratios in the sine rule. So sine of C divided by 7.5 is the same as 5 divided by the sine of 32. So I've got my ratio the wrong way around. Let's keep the sine in the numerator, otherwise there is no ratio. So sine of 32 divided by the side opposite it, which is 5. So we're going to get sine C. Let the magic machine process all the values. So we have sine 32, and we're going to divide it by 5, and we're going to multiply it by 7, 5, and we get a ratio of 0.79. But we need the angle. So to find the angle, we have a magic button. Voila. Let's see what our angle is. There we go, 52.64. That would be our angle, 52.6. So we've got the angle, and we would like to know the area of DEC. How big is that area? What does the area rule say? We've got to have an SAS relationship, so you could use 7.5 times sine 32 times 9.4, or you could use 5, the green angle, and 9.4. I would always, if I have an option, work with the given values, because I know those are correct. So if we work with it on the side here, the area of triangle DEC would be a half of 7.5 times 9.4 times the sine of 32. Get your formulae correct. The area rule involves sine and not cos. And let's see what our value is going to be. 0.5 times 7.5 times 9.4 times sine 32. And we get an area of 18.6 squared meters. Let's see if we'd run 7.7. Let's not get it wrong. So that would be 0.7 squared meters, 7 squared meters. Right, and then we have the height, EF. How big is this length here? Okay, well, that's perpendicular. So we really have got a right angle in here. So I'm not going to need any rules because that's opposite, that's the hypotenuse. So I really have the sine of 32. So if I use the length, in fact, it's EF that we need. We need this length over here. And we know that that's 3.5. So we really only need this portion here, EG, which is opposite 32. So sine 32 is equal to EG sine 32 is equal to EG divided by 7.5. So our magic machine is able to do these amazing trig ratios for us. Sine 32 multiplied by 7.5 gives us 3.97. So EG is 3.97, which added to 3.5 will give us this final value of EF, plus 3.5 gives us 7.47. So 7.5, so EF is 7.5 meters. Okay, so that was the plan of a house that we could use some trigonometry on. Let's see another possible question. Okay, this is a photograph of an Airbus A380, and it is the largest passenger airplane in the world, and let's see how we can use trig. In the diagram below, the top view of the plane is shown, and the wingspan of the plane is 79,8 meters as shown by the line DE. So from tip of wing to the other tip is 79,8. And if it's given that the length from the wing to the middle of the plane, dr, from the middle of the plane to the tip of the wing is 43,4 meters, and DE, we've already got that. Determine, round it off to one decimal place, the size of angle DRE. So we can actually take the model, the real model, and we can create lines and angles to show what that model looks like mathematically. And so we would like to find out what is this angle, what is the size of that angle. And grade 11s, what would you say? You've got side, side, side. If I have three sides, how do I calculate an angle? Which rule helps me to find an angle when I have three sides? Yes, it's the cos rule. So this would be the side that's opposite the angle. That's how we start the formulae. So it's 79,8 squared. We're then going to equate it to the other two sides squared. So it's 43,4 squared plus 43,4 squared. We're then going to take away the product of 43,4 times 43,4, and we're going to multiply it by the cos of angle R. We then are going to solve for cos R by taking away these values and dividing by that. Let's hope that our calculator this time behaves, because the last time it did some strange things. And obviously it's not my fault, eh? It's all the calculator's fault. All right, so 79.8, we're going to square that. We're then going to take away 43.4 squared. We're going to take it away again, minus 43.4 squared. Let's just go back here. There we go, delete, delete. Let's go one more and let's delete that. Right, 43.4 squared. And we're then going to divide. Aha, I know why I did this the wrong way around the last time. Because grade 11s, remember, I want my numerator. And if I want my numerator, I need to have a bracket for that answer. And this is when you wish that the calculator had a button that said end. Otherwise, we'll just keep going all the time. Right, divided by -2, and we're multiplying it by 43.4, and we could have squared it because it's two of those factors. And we can then say, right, what's the ratio for that? There we go. So we now have a ratio of -0,69. Okay, before we proceed, grade 11s, if my cos ratio is negative, what indication do you get to the size of the angle that angle R is, if it's negative? Can you tell me? If the cos ratio is negative, it implies that angle R is obtuse. So I'm expecting angle R to be obtuse. If it's not, something is wrong and I need to go and find out what it is. So magic button for the angle equals 133,7. So there is that angle that's sitting there between the two wings. And then what is the area of DRE? What is that area there? What rule involves area? It would be half of side angle side. So it would be 43,4 side, side, and then the included angle is the sine of the angle we've just found, which is 133,7. So that area would now be, as you can see, we cannot do trig without our machine. We now have the sine of the answer, and we're going to multiply it by, or divide it by 2, and we're going to multiply it by 43.4 squared, and that gives us 681,3. 681,3 squared meters. And we've got a very simple situation where we were able to just in 2D demarcate the wingspan of the plane and the length of the wings in terms of finding the angles and the area as well. So it really is a 2D problem. The challenge question that you're all busy with at the moment has got a vertical plane and it's got an oblique plane as well to work in. But let's proceed with our next question. Okay, the angle of elevation, let's just see here. In the diagram below, a tree is situated on the opposite side of a river, R and T. So here's RT on the bank of the river, and the tree is on the opposite side. Lovely tree, I like it. The angle of elevation of S, the top of the tree from T is 49 degrees, and E is a point vertically below S, and in the same horizontal plane as R and T. RT is 12 meters, RT is 46, and ERT is 39. Now, grade 11s, don't switch off to when you have a whole kind of a comprehension. If you have a comprehension, read it once just to get the context. So I've now got the context. There's a river, there's a tree on the opposite bank, and they've given us some angles and some measurements. Read it again to extract what those measurements are, to make sure that you've got every measurement on the diagram. And then you need to read it again to make sure you haven't missed anything. Because when you first get thrown with a problem, it's difficult to digest all the important facts at the outset. So be patient, read it once, read it twice to extract all the measurements, and read it the third time to make sure you haven't missed anything. So let's go to it. So we've got the context. We now want to see the values. The angle of elevation of S. So somebody is standing at T. They're looking up at S. And when they look up, that's the line of sight. It makes 49 degrees with a horizontal. And the horizontal would just be this line that's directly opposite to the base of the tree. E is a point that's vertically below. Why do they say this? Do you think that this is just here just for fun? Vertically below. Anything in mathematics that's in a vertical relationship means that you are at right angles to the horizontal. So there's my little right angle to indicate that I've got a perpendicular. And in the same horizontal plane as RTE. So these are forming a horizontal plane, these 3 points. So there's my horizontal plane. I like to color it in because whenever you get 3D diagrams, it's very difficult to be able to draw it. You're trying to, on a 2D shape, draw what should be in perspective in 3D. And for those of you like me who are not very arty in drawing these perspectives, it's quite difficult. So what I try and do is color in the horizontal plane just for emphasis that that's my horizontal and my vertical is standing up there. We then have RT is 12 meters. There's RT, it's 12 meters. And RTE is 46 degrees. RTE, that angle on the ground, is 46, and ERT is 39. ERT is 39. So these lines that have been drawn from the foot of the tree to the opposite bank, from the foot of the tree to the opposite bank, these lines are making those angles on the horizontal. Okay, let's see what we need to focus on. Determine ES, the height of the tree, rounded off to 1 decimal place. So ES, that height of the tree, is it possible for us to find that length? Well, if we, in the white triangle, we're probably going to say there isn't enough information. We have how much? How much info do we have? We have one angle. We've got 49 degrees. So it's obvious that I need to go and find something else before I go and find ES. In this white triangle, I need to find ES. I only have 49 degrees. I am short of information. So I need to go and extract that extra information from somewhere else. And the only other place I can go is this yellow triangle, the horizontal plane, because it shares ET as a length. So if I can find ET, then I'm good, because I then have a length and an angle in a right angle triangle, and then I can find ES. So our job needs to take a step back. We need to go and find ET, and we have ET is opposite 39, and the 12 is opposite E. So now we still have some missing information. There's E. Could you find angle E? Is it possible to find angle E? And you're all shouting at the screen because you're saying, yes, I can see it, I can see it. It's an angle sum in triangle. They're the other two angles, so that's great. So let's find angle E. Angle E would be 180, take away the 39 and the 46. And the reason is angle sum in triangle. And if we do our little sum, okay, we don't want to pop round, so let's just go there. We have 180 minus 39 minus 46, and we get 95. So angle E is 95. Now, where will we going with this information? Because 12 is opposite 95, and the one that we want is opposite 39. So we're going to start off with ET, because that's what we don't know. So ET divided by sine of 39 is equal to 12 divided by sine of 95. And get into the habit, grade 11s, of actually filling in. This is 95, so let's fill it in. As we calculate it, we fill it in. So ET is equal to, let's see if it will move now. Okay, we're a bit, there we go. So we have a 12, and we're going to divide it by sine 95. And we're then going to multiply it by sine of 39, and we get what? We get a 7,6 if we round off to one decimal place. So we've got a 7,6 meters. That is the distance between the foot of the tower and person T, that's on the other bank. Okay. And then determine the width of the river rounded to one decimal place. Assume that RET are points on the banks of the river and that the width is constant. So the width of the river, let's go and see where the width of the river is. So now, we haven't finished the question yet because we found ET. This was that length ET that we were searching for that was common to both triangles. But we're now going to find how long ES. That was the first question, so we kind of just, well, I just abruptly stopped there. So let's keep going. In triangle SET, we have this length is what we want to know. It's opposite 49, and this distance is adjacent. So the cos of 49 is equal to adjacent, which is the side we've just found, which is 7,6, divided by, no, it's not cos 49, it would be tan, because this is adjacent and that side is opposite. So what joins adjacent and opposite? It's our tan ratio. So we have the tan of 49 is SE over ET, therefore SE would be ET, which we've just found, times the tan of 49. So we have, no, we want to delete, there we go, clear. Tan 49, and we're going to multiply it by 7.6 to give us 8,74. And that would be meters, that would be the height of the tree. That's how tall that tree is. And I think, AB, let's take a quick break so we can look at the challenge question.
Well, Masters, we'll see you after this break. Welcome back, Mindsetters. Just a quick reminder on your test yourself, the questions that are there for you guys are not multiple choice, so do provide full answers. But now, without any waste of time, let's get on our Get Connected competition and draw two names because earlier on, Mpumulo won. So let's see. I'm also not cheating, Dina. First person is Dineo Musho. Musho. Congratulations to Dineo Musho. Let's get the last person for today. Last person is Chris Mashire. Chris Mashire and Dineo, congratulations to you guys. You've both got yourselves 55 Rand airtime, probably sponsored by Vodacom. Keep entering, share the picture on Facebook. Dina, back to you.
All right, grade 11s, let's just finish off with the width of the river that we were speaking about in the previous question. There is no width that's been marked for us, so I'm just going to mark off the width of the river as being constant, as being the shortest distance from the bank to the bank. So we're assuming that this green length is the width, and wherever you are at the foot of the tree to the other side, opposite, the shortest distance would be the perpendicular distance, and then we would measure the width of the river as that distance. So if you're now in this little triangle, which is getting very busy, this green triangle, we've worked out that that length is 7,6. We've got that angle is 46. It is a perpendicular. We don't need any sine rule. We can just say that the length we want is the opposite. That length is a hypotenuse. So on the side here, sine 46 is W over 7,6, which makes the width of the river 5,5. And we do want to get onto one or two of the questions from the viewers, and we also want to look at the challenge question. And I think before we do the challenge question, what was that lovely question we got about AAA?
Okay, can you get on the challenge question and I'll give you after it?
Okay,
Promise.
super. We'll do that. Okay, let's go on to the challenge question. Okay, I'm not going to read through the information because the information was all on here on the diagram, and we had lengths of 2,000 meters. 1,000 meters was PB. We had this angle of 60, and I'm hoping that you can see all the verticals and horizontals here, because ABKJ was a horizontal, and then we had this DCKJ, which is a vertical, and then we've got these oblique planes, BKC, which is a vertical plane. That's a vertical plane. This one here is a vertical plane. This PBC is an oblique plane. So I'm hoping that you'll be able to use your power of visualization to see all those planes. And if you're struggling, you can actually make a model and just see how it all works, especially for those who are going to go into engineering. Then you can really certainly make those models out. We would like to find out what is BC, CK, and BK. And if you look here, this oblique plane here, there's a right angle at the top there. So that is actually a right angle triangle, which makes this the hypotenuse. It looks very odd because it's drawn obliquely, and it doesn't appear that angle C would be right angle, but that's how they've given it to us, so we'll work with the given information. We want the length of BC, and BC is this length here. And we have that this length here is 1,000, that angle is 60, we've got this angle over here is 30, and we've got that bit there is 50. Let's see if we've got missing any information. PT is 50, and yes, the angle of inclination is 30 degrees. So we've actually got this length over here, which, if you think about it, that you're in a right angle triangle. So if that's right angled there, there's my right angle. Then this length here, I don't need any rules to help me, because this is my adjacent side and this is my hypotenuse in that triangle. So if I'm going to draw this green triangle again by extracting it from the plane and just drawing it in 2D. We've got angle C is 90, and we've got the side opposite that is PB, and that is 1,000. And then we've got angle B is 60 degrees. So finding CB, that is my side that's adjacent to 60. So a cos of 60 degrees would be equal to adjacent, which is CB, which is what I want, divided by 1,000. And so CB is just 1,000 times cos 60. Cos 60 is the same as sine 30, which is a half. So half of 1,000 is 500. So this is 500. Then we have CK, which is this length over here. And if I'm now in this right angle triangle, that is opposite 30 degrees, because that's my angle of elevation. So that's opposite 30. And we've just worked out what the hypotenuse is. So therefore, the sine of 30 degrees is equal to CK over 500. So CK is equal to a half of 500, which is 250. So this length here is 250. And then how are we doing, mind setters? Learn extra? Are we getting those values? Did we get anybody with 500, 250? Right, and then we have BK, and BK is this length over here, the diagonal, which in that figure there, in that horizontal, it's possibly going to be the same as JA. And if we use the same terminology what we did, this is a right angle here, this is a vertical. So if I put in a right angle there, I'm actually going to make it quite messy, but CK is a vertical, so it makes this vertical plane, this yellow vertical plane, and I want BK, which is adjacent to that, so therefore cos 30 will be equal to adjacent, which is BK, divided by my 500 that I've worked out. So BK is equal to 500 times root 3 over 2, so it's 250 root 3, because they've said that answers must be left in third form. And then the length of PC would be in this right angle triangle here. PC there would be opposite 60, and I have that as 1,000, which is my hypotenuse. So sine 60 would be equal to, sine 60 is opposite, would be PC over my hypotenuse, which is 1,000. So 1,000 times root 3 over 2 would be 500 root 3. That is PC here. And then finally, the length of AT, working in this triangle over there. I have that. I can also work out this length, because this length I can work out from having worked out 500 root 3, so I can find that length. I can find this length, it's the same as that side there, and I can use Pythagoras to find AE. And once I've got AE, I can then also work in this triangle over here, because this is 250, so this length here is 300, and having this length, having that length, I can use Pythagoras to work out AT. So I could work out AT using Pythagoras. Okay, grade 11s, I hope that has been useful, and I'll hand you over to Abram.
Thank you so much, Gina. Thank you, my sisters, for tuning in, and congratulations to Kulufelo Munyawati. This case calculator is coming your way. We love you, my sisters. Peace.